Hey guys, and welcome to Properties of Exponents. By the end of this video, we're going to simplify expressions using properties for exponents, use the definition of a negative exponent, and in the next video we'll get into scientific notation. We won't do that here today. So the very first thing we need to figure out is, okay, well, what is our exponent notation? So if we have an a to the m, well, that means we have m copies of a. For example, negative 9 to the fifth means we have 5 products of negative 9. So that's the first thing. That's what exponential notation is. And now let's get into our first property. So our first property is this product property. So what happens if I multiply two variables together, the same variable that have different exponents? So it could be the same exponent. Well, this guy here means I have 2 copies of x. X cubed means I have 3 copies of x. They're all being multiplied together. So basically I get to add all of my variables together. 2 factors here, 3 factors here, so 5 factors altogether. So the rule is when we multiply like bases together, we add the exponents. So to multiply like bases, we add the exponents. That's what's going on here. So that's property 1. And let's look at some examples. So what do we do? And let's already go to the challenge example here. So we're going to do C. Okay, well, we still need to multiply our coefficients together. So 2 times 3 is going to be a 6. And then a to the 7th times a to the 1. So we add the exponents. That's going to be a to the 8th. So that's for that guy here. Okay, what about for this guy? D to the 4th times d to the 5th times d squared. Well, that's going to be d to the, add the exponents. So 4 plus 5 plus 2. So that is going to be d to the 11th for that guy there. So again, multiply like bases, add your exponents together. Alright, let's look at something else. Okay, so that was multiplying exponents and like bases together. Now what if we're dividing like bases? For instance, what if we have this x to the 5th over this x squared? Ooh, that's an ugly color. Let's go back to pink. This x to the 5th over x squared. Okay, well, a little. Well, x to the 5th means there's 5 copies of x. X squared means there's 2 copies of x. Okay, well, we can cancel the 2 copies up top with the 2 copies down below. So that's x cubed. So the rule is when we have like bases, we subtract the exponents, and it's numerator minus denominator. Okay, so if we have m over n, it's a to the m minus n. So when you have bases as a quotient, we subtract the exponent, and it's numerator minus denominator. Alright, let's look at some examples. Okay, well, let's go into D. Okay, well, 7 cubed over 7 to the 5th, so it'd be 7 to the numerator minus denominator. So that would be 7 to the negative 2, and this is going to come into our next property. But if we have a negative exponent, we take the reciprocal, so this would end up being 1 over, also better known as 1 over 49. Okay, so again, subtract the denominator from the numerator. First, let's see, will be, so if we have 3 to the 10th over 3 squared, so that would be 3 to the 10 minus 2, that would be 3 to the 8th. Okay, so again, like bases is a quotient, subtract the exponents, and it's always numerator minus denominator. So as we move on, we're going to go into the very special, one of my favorite properties. We're going to go into the zero exponent property, which basically says anything to the 0 power is 1. And I mean anything to the 0 power is 1. We have parentheses, and there's like a bunch of garbage in here, all that to the 0. It doesn't even matter what the garbage in there is, it's all 1. Anything to the 0 power is 1. And I'm talking like if you have 3 pages of polynomials all wrapped in parentheses, oh, take it to the 0, oh, it's 1. Everything to the 0 power is 1. So for A, let's see, 9 to the 0. What do you guys think it is? Oh yeah, it's 1. N to the 0. Oh yeah, what do you think it is? It's 1. Q to 0. What do you think it is? Oh yeah, it's 1. Anything to the 0 power is 1. That's so great about this. Okay, next is the negative exponent property. So this is what we got into a little bit in the example. But basically, if you have an a to the negative n, or just a base to the negative exponent, we're going to flip it over. Okay, so if it's regular a to the negative n, it becomes 1 over a to the n. And if the negative exponent is already in the denominator, again, we flip it over. So we're going to flip it, that comes up to the top, and that's where the a to the n comes from. Now what does this look like in practice? Again, just saying negative exponent, flip it. So for a, x to the negative 5, flip over x to the 5th. 10 to the negative 3rd, flip it over 1 to the, and the exponent becomes positive when you flip it. Over 10 to the 3rd, or this is also better known as 1 over 1,000. For 1 over y to the negative 4, oh, negative exponent is denominator. Let's flip it up into the numerator and make it positive. Becomes y to the 4th. And 1 over 3 to the negative 2, oh, let's flip it over and create the exponent positive. This is better known as 9. Okay? So negative exponents, wherever the exponent is, if it's in the numerator, put it in the denominator. If it's in the denominator, put it in the numerator. And then make it positive. After you flip it, you make it positive. So that's negative exponents. Let's go to our next property. So if we have a quotient to a negative power, this is really nice. We just flip the whole thing. Okay, so if we have a fraction, or what we call quotient, to a negative exponent, so notice it was a over b, now it's b over a to the positive. So let's look at this guy. Okay, so following those same rules, okay, flip what's in there. And then if that's negative, now that becomes positive, boom, done. Okay, same thing here. Whatever's inside, we flip it. Negative y over x. So that's been flipped. The negative on the outside now becomes a positive. So flip your quotient and the exponent then becomes positive. And let's see, what's our next property? Oh, one of my other favorites, power property. So if we look here, well, what if we have something in parentheses that already has an exponent on it and we're raising it to a power, so like a power to a power. So x squared cubed means I want 3 copies of x squared. Okay, x squared, x squared, x squared. And we know by product property that when we have this, we add up all of our 2's. So we do 2 plus 2 plus 2, so 6. So the rule here is when we raise a power to a power, we multiply. So to raise a power to a power, multiply the exponent. So product property is add, power property is multiply. And these get confused often. So let's see here. Y to the 5th to the 9th. What is 5 times 9? So that would be y to the 45. 4 to the 4th to the 7th. Well, that would be 4 to the 28th, because 4 times 7 is 28. Y to the 3rd to the 6th. Well, that would be y to the 18. Y to the 5th to the 4th. Well, that would be y to the 20th. Okay, now product property takes over and we add those guys. So that'd be y to the 38 here. So product property, multiply your exponents. And then what if we have a bunch of stuff? So if you have a bunch of stuff in the parentheses and it's all raised to the power, product or power rule still takes over. It's just basically we distribute this exponent. So if you have a bunch of stuff in parentheses raised to a power, the exponent goes to everybody. So, and this is important, and we're going to use every single example for this because this gets confused often. So, the 3 goes to the negative 3, it goes to the m, and it goes to the m. So this is going to be negative 3 cubed, this is going to be m cubed, and this is going to be n cubed. So I'm going to clean that up. So negative 3 cubed is negative 27, m cubed is m cubed, and n cubed is n cubed. Okay. Alright, what about for b? Negative 4 to the 0, oh great, anything to the 0 is 1. A squared to the 0, oh great, anything to the 0 is 1. B to the 0, oh great, anything to the 0 is 1. Hey, this whole thing is equal to 1, great. Okay, c, so the negative 2 goes to the 6, and it goes to the k, so this would be 6 to the negative 2 times k to the 3 times negative 2 is negative 6. We clean this up with negative exponents. 6 to the negative 2, it is in the numerator, so now it's in the denominator. K to the negative 6 is in the numerator, so now it's in the denominator. Change it positive, and then we'll just throw 1 over the top, and we're done. Okay, for d, the 2 goes to the 5, and the 2 goes to the x, so this would be 5 squared. Power rule, negative 3 times 2, x to the negative 6. 5 squared is 25. Negative exponent rule, x to the negative 6, flip it over so that guy goes in the denominator, and then make the exponent positive, and we're done. So next, if we raise a quotient, so this is all just derivative of power rule. Quotient to a power, the power distributes to both pieces. So let's look at d, because it's the most complicated. Okay, so this 2 is going to go to the 4, this 2 is going to go to the p, and the 2 is going to go to the q. So this would be 4 squared p, negative 3 times 2 is negative 6 over q, 2 times 2 is 4, so over q to the 4th. Now we check for negative exponents. Alright, 4 squared, let's clean that up to 16. P to the negative 6, hey, negative exponent, so that gets flipped into the denominator. Q4, you can stay by yourself. Okay, so that would be our final answer there. So quotient to a power, the power just gets distributed, kind of same thing as before. And let's see, so here's the summary of our rules. Let's make this a little bigger. There we go. Product property. When multiply like bases, we add the exponents. Power property. Power to a power, multiply exponents. Product to a power, the power distributes. Let me go back to pen. So power property. Exponents distributes. Quotient property, we subtract, and it's always numerator minus denominator. Zero property, anything to the 0 power is 1. Quotient to a power, the power distributes to the a and to the b, to the numerator and the denominator, and everything in there. Negative exponent property, wherever the negative exponent is, flip it and make it positive. So if it's in the numerator, flip it, make it positive. If it's in the denominator, flip it, make it positive. Quotient to a negative exponent. So here's your quotient, negative exponent. The negative exponent you can either thinking as distribute, and then we got to flip it, or from a to b, flip the whole fraction over, so it becomes b over a, and then the exponent becomes positive. That's quotient to a negative exponent there. Okay, so that's it for this video. In the next video, we'll do scientific notation. And as always, if you have any questions, please don't hesitate to ask. Thanks, guys. See you in the next video.